Welcome to the video lecture on partitioning. So partitioning is an interesting topic in that when you get to the physical database design, we start talking about performance and how to enhance performance. And partitioning is a way to do that. We have basically two different ways which can be combined, horizontal and vertical. We've got horizontal partitioning, which distribute the rows. So first of all, when I talk about partitioning, I talk about breaking down into smaller pieces. So we may have vast amounts of data stored in a particular table. For instance, we have millions of students, right? For instance, if we're a large university, we may have millions of student records that we're keeping track of. Certainly here at Hofstra, we have millions of records, terabytes of data, and it is in various scenarios partitioned. Horizontal partitioning, right? So we're going to try to chop up this entity horizontally, which means by rows. So if you think about graphically what a table looks like, think of it as a grid, right? Your rows are stacked one on top of the other. Your fields are placed one next to one another. So when we do horizontal partitioning, we're slicing it horizontally. All right, so we're cutting it by the rows. So this is distributing the rows of the table into separate files, sometimes on different disks altogether. Remember, physical hard disks in storage. So separating them onto different disks may also improve performance. So when different users need access to different rows, you want to use horizontal partitioning. And there are different types. There's key range partitioning, there's hash partitioning, and there's composite partitioning. Key range is essentially taking your primary keys, setting up a range and saying, all right, everything whose primary key goes from 1 to 1,000 goes into this partition. Another one is, 1001 to 2000 goes into this partition, and so on. Hash partitioning uses a hash function. So think of hash as just a function out there that tries to determine where this record should go. So there might be a function associated with the primary key and, say, a zip code to determine where this record should go, what partition this record should go into. The hashing functions can get very sophisticated. Or there's also list partitioning, which isn't really listed here. It's kind of like key range, in that I say, everybody from Connecticut goes there, everybody from Vermont and New Hampshire goes into a different partition. So you can set up lists, for instance, by state, to determine what records go into what partitions. Or you can use composite partitioning, which uses advantages of the different types of partitioning and kind of combines them together. So vertical partitioning is when we're actually carving up a logical relation into several separate relations. So now it's almost like we're building other tables that have one-to-one relationships, one to another. So this is useful for situations where different users need access to different columns. So for instance, if we were storing the the salary in the employee table, not everybody needs to see the salary part of the employee table. And as a matter of fact, for security purposes, we may want to partition that off. Things along those lines. Unfortunately, the primary key must be repeated in each file, and that's kind of where we get into that one-to-one relationship looking scenario. And then we also have combinations of horizontal and vertical to partition data out. Partitions often correspond with user schemas or views used by users, and we're going to get into views later on in another video. There are advantages and disadvantages to partitioning. The advantages are, it's efficient, right? It makes it increases performance. Records that are used together are grouped together. It's local optimization, so each partition can be optimized. So if there's If there are records associated with a particular partition that are, say, old and read-only, I can put them on a read-only disk. So there are local optimizations. We talked about security. We can segregate data so that not every user can see it. Recovery and uptime. If I break this down into smaller files, it takes less time to back up each of the different partitions. And going back the other way, it also makes it faster to recover from that. And we can set up load balancing. So as I said a few minutes ago, we can store different partitions on different disks. So if I need to read the entire student table, but the student table is spread out amongst 17 different hard disks, well, each one of those hard disks has a read-write head. So I'm going to be reading it five times faster than I would if I only had it on one disk. Okay. There are some disadvantages of partitioning. The access speed, right, that we're expecting. And again, remember, we estimated how fast we're going to be able to get to the data when we're looking at performance. It can be, the access speed can be inconsistent now because we have to jump from partition to partition to put data together. It can be fairly complex, as you might imagine. This is getting pretty hairy when we start doing some of the pretty crazy partitioning that I've seen out there. And it could require extra space, or it could take longer to update. You know, we could have duplicate data for multiple partitions, especially if we're doing this vertically, right? So there are advantages and disadvantages. And so yeah, these are, again, the partitioning methods that are allowed in Oracle 11g as far as horizontal. We talked about the range partitioning, we talked about hash partitioning, talked about list partitioning, and we talked about the fact that we can do a composite of the different approaches. So that ends my video lecture on partitioning.